Hi, in this video we're going to talk about vector components. In the last couple of videos where we were talking about adding and subtracting vectors, we know that we can take any two vectors, add them together to get a third vector, which we call the resultant. Basically, components is doing the same thing but in reverse. We're going to take a vector like the one drawn here and break it up into the two vectors which when added together give us this as a resultant. So in other words, this vector is made up of this vector in the x direction plus this vector in the y direction. These are the two components. So this vector here we call the x component. So I'm going to label it Vx. And to find the x component of this vector v, it's the adjacent side of this triangle. So it would be v times cosine of theta. This is the y component. It's the opposite side of the triangle, so this would be v times sine of theta. And that's how we find the two component vectors that add up to give me this resultant. They don't have to be just x and y components. We can find north and south, north and west, or south and west, or south and east. We can even find horizontal and vertical, or parallel and perpendicular components, as long as they're two components that are at a right angle to each other. Okay? It's important that when we're dealing with components, that we're always looking at two vectors that are at 90 degrees to each other, because then we can deal with a very simple Pythagorean theorem to find the resultant. The other place that vector components come in handy is when we're trying to add or subtract more than one vector. Suppose here I was asked to find the vector a plus b minus vector c. Oops, there should be a c here. So these three vectors are not going to give me a nice right angle triangle or even a triangular vector diagram. Right? If I tried to draw it right now, I would have vector A looking something like this, vector B off in this direction, and then to subtract C, rather than drawing it this way, I draw it in the opposite direction. So C is going to go off in this direction. So I have a very complicated looking diagram where the resultant, when I draw it in here, is not a nice right angle triangle or a triangle at all. So how do I find that vector, a plus b minus c? Don't forget this is c here. Well, what we do is break each of these vectors into their components, the component in the x direction and the component in the y direction. So for vector A, we're looking at this angle, 45 degrees. So A, the x component of it is 10.6, the magnitude here, times cosine, it's the adjacent side, it's the x, of 45. That gives me 7.5 meters. The y component on this side is 10.6 times sine of 45. It's the opposite side. Because it's 45 degrees, the two components are the same magnitude. For vector b, we have to remember that the x component of b is already in the negative direction. So we have to include this negative sign, negative 11.8 times cosine of 65. The x component then is negative 4.99. The y component is positive. And for vector c, again, the x component is negative, and the y component is also negative. So I've broken each of these vectors up into their x and y components. And to find that vector, which was a plus b minus c, I'm going to look at the x and the y in each of those vectors. So the x components, I'm going to add and subtract them together. So the 7.5 plus negative 4.99 minus negative 3.21. You have to be careful with the sign of these components, right? You're adding vector b, but it's already negative. You're subtracting c, but it's also negative. So those three numbers together give me an x component for my resultant vector. Then I do the same thing in the y direction, and I get the y component of my resultant vector. So what that means is I've now found the x and the y component of this vector. The x component, maybe I'll do it here, is very small, and the y component is quite large, giving us this vector here, which is my resultant. And I can find the direction of it because it's a nice right angle triangle, and I know the magnitude of these two sides. So to find that resultant, I use the Pythagorean theorem. So I have my x component, which is 5.72 meters squared, and I'm going to add to that the 30.17 meters for the y component. And what I find is that the resultant here is 30.7 meters. That's the magnitude of this vector. For the direction, again, I'm looking at a right angle triangle, so tangent of that angle is the opposite side over the adjacent. And in this case, the opposite side is the y component, so 30.17. And the adjacent side is the x component, which is 5.72. So I end up with an angle of 79.3 degrees. So that vector that I was looking for, a plus b minus c, that's a vector that is 30.7 meters in length at 79 degrees, 79.3 degrees. And since we don't know whether this is north, south, east, or west, or any other direction, we can just assume that it's x and y. So that is obviously the angle that is above the positive x-axis. So this is above the positive x-axis. Okay, so again, just to review, what we did was to break the three vectors up into their components and then find the x and the y component of the resultant. This is the x component of my resultant and the y component. From there, it's just a basic right angle triangle, and you're solving it using Pythagoras and tangent. So that's how we deal with vectors and components. If you have any questions, you can track me down in class.